So today's topic is exponential expression. And before we do this topic, let's just do a little warm-up. I'm going to give you 2 minutes only. 2 minutes only to complete this warm-up, all right? So first of all, let me provide a space for the topic. So I will say topic. I will write what the topic is going to be here. But here I will say warm-up. This warm-up is going to be super easy. Very, very easy. So, but let's check it out. Okay, that's the warm-up. You have 2 minutes.
I finished.
All right, thank you. Okay, so now let's go. What's the first one?
4.
Just say your first name and then give me an answer.
Cindy, 4.
Okay, next person. What's the second one?
Bint is 4.
Okay, when I say okay, that's basically I heard what you said. My okay doesn't necessarily mean that you got it right or wrong. I just don't want you to misinterpret that. I'm not saying that you got it right. I'm not saying that you got it wrong. I just said I heard. Okay? All right.
Okay.
So first person said that the first one is 4. Second person said that the second one is 4. Then third person, what do you say about the third one? So this is 1, 2, 3, 4. Okay, so the third person said that the third one is what?
16.
16. Okay, fourth person said that the fourth one is what?
3.
Okay, so now let's check it out. 2 plus 2 is 4. 2 times 2 is also 4. Now, when you come to 2 raised to power 4, let's try to expand it and verify whether what the answer that we were given is correct. So 2 raised to power 4 can be written as 2 times 2 times 2 times 2. Is that correct? Look at what I wrote and say, when I say is that correct, for you to speed up the process of your response, all you need to do is just press your space bar. If you press your space bar, it will achieve one thing. Guess what it's going to achieve? It will unmute you. You see, it's going to unmute you if you are on mute already. If you're on mute already, it's going to unmute you so that you can make your response. So 2 times 2 times 2 times 2. That's 2 raised to power 4. That means we repeated the multiplication 4 times. All right? And 2 times 2 is 4, and another 2 times 2 is 4, and 4 times 4 is 16. So 16 is also correct. Then the fourth person said that, Cindy, can you help us explain how you got 3?
Wait, hold on. I basically just plugged in the numbers.
What number are you plugging in? Just picked up any number and plug in there. How did you determine the number to plug in? That's what I'm trying to understand.
You take the root of both sides and you solve them.
Okay, you take the root, square root or fourth root or what? Because you have on the left side, you have x raised to power 4. On the right side, you have 81. So when you say take the roots, do you mean we should take square root? Or do you mean we should take fourth root? Or which root do you want? Unmute yourself. It looks like you are in a quiet environment so that you can talk fast.
That's the square root of 4.
Okay, so you see, that's why I'm asking this question. You cannot just take the square root of 4 because 4 is an exponent. Am I making sense?
Yeah.
But you can certainly take the square root of both the left side and the right side. You can take the square root of both of them. So that's a good process, but you cannot just take the square root of 4. The reason why you cannot take the square root of 4 only is because 4 is an exponent, and that exponent is attached to a number. So basically, you are having x raised to power 4. It's like saying x times x times x times x. All right, but let's try. What you said, taking square root on both sides is actually correct, but not taking it on 4. That's where the difference is. So let's do what you said. Let's take square root on both sides. So we are going to, so this one, solution, we can take square root of x raised to power 4 and equal to square root of 81. X raised to power 4 can also be written as x raised to power 2 multiplied by x raised to power 2. So if you take square root of x raised to power 4, it is going to give you x squared equal to, so what is the square root of 81? Somebody unmute yourself and respond. What's the square root of 81?
9.
9. That's correct. Square root of 81 is 9. Are we done?
No.
Okay, we're still finding x, not x squared. So what else can we do?
You simplify it,
Yeah, by doing what?
dividing it by 2.
We cannot divide it by 2 because 2 is an exponent. Do you understand? Now let me make this point. X squared is not equal to 2x. It is not equal to 2x. However, x squared is equal to x times, so we cannot divide both sides by 2. Am I making sense now? So now we can repeat what we did in the first process, which is to take square roots on both sides again. We can repeat that. So we can repeat and say square root of x raised to power 2 equal to square root of 9. So let's do the simple one first. What is square root of 9? Somebody says something. Edwin, go. I'm going to be
3.
calling names now since nobody wants to volunteer except Cindy. So I'm only talking to Cindy. Out of how many students? Yes. Square root of 9 is what?
3.
Okay, so we just write 3. How about the square root of x squared? That's actually x. So 3 is correct. So this is one way. This is one way of doing this. Here's another way of doing it. Here's another way of solving the same problem. Here's another way of solving it. So let me go back here and let's see a different way of solving it. Now, if you look at 81, so let's write on our left side first. X raised to power 4 is equal to 81. Is there any way we can break down 81 in to smaller numbers, especially in factors? Can we break down 81 in terms of factors? Can 81 be 9 times 9? Is it possible?
Yes.
Okay, so 81 is 9 multiplied by 9. On the other hand, how about 9? Can we break down 9?
No. Wait.
In terms of factors?
No. Wait, yeah.
Yes,
6
absolutely.
and 3.
So it can be what?
6 times 3. 3 times 6.
3 times 6 is 18, not 9.
Oh, wait.
3 times 3 is 9.
3.
Multiplied by another 9 is 3 times 3. So in the real sense of this, 81 can also be written as 3 raised to power 4, and that's x raised to power 4 on the left side. So x exponent 4 and 3 exponent 4. So if you look at the left and the right side, if the exponents are exactly the same, it means the base is equivalent. What did I say? Somebody repeat exactly what I said now. I need a repetition. Just repeat what I said. So if the exponents are the same, you see, this is x raised to power 4, and this is 3 raised to power 4. So the exponents are exactly the same. That means the base are equivalent. The base are the same, are equal to each other. So it means that x is equal to 3. If, on the other hand, if the base are the same, it also means that the exponents are going to be equivalent. I need somebody to repeat that. Let me say it again, but somebody has to repeat it. If the base are the same, it means the exponents are equivalent. I need a
If the
repetition.
base is the same, then the exponents are equivalent.
Exactly. So now let me give you an example. Let me give you an example. If I have 2 raised to power 5, no, 2 raised to power x, rather, and then I have 2 raised to power 5. So in this case, the base is 2. The base are the same. That means the exponents are also what? Equivalent. That means x is equal to 5. That's what it means. All right. So this is very basic. This is very, very basic. What we just did right now. This is very, very basic. So now, but we are not done. There are still so much more. So all we just did right now is to use an example of the warm-up in order to explain some concepts. So now let's continue. Let's continue. By the way, the topic is exponential expressions. Exponential expressions is the topic. Okay, so now let's look at other numbers that can appear in form of exponent, and let's see how we can deal with it. This topic can also be, you can also call it rational exponent. So you can also call it what? Rational exponent. I'm going to tell you why it is also called rational exponent. But let's start with this example. When we say a number 4 square root of 4, square root of 4. So what is square root of 4?
2.
2. Yes, square root of 4 is equal to 2. Now, here's the question. Here's the question, which is the main thing. Is there another way of writing square root of 4? Is there any other way of writing square root of 4 other than writing 2? 2 is the solution. So is there any other way of writing the left-hand side?
2 times 2. What?
Yeah.
Yeah, 2 times
There is
2.
I don't think so. Wait.
You mean like 2
Another
times 1?
person, Cindy, hold on. Let another person say something.
Okay, sorry.
No, don't worry. No, you are right. I'm not saying that your answer is right. I'm saying you are doing the right thing. I just want to, since somebody else volunteered, let's hear from the person. You are doing the right thing. That's exactly what a student should be doing, participating. That's what it's called. So I appreciate that. So now somebody wanted to make a comment, so I want to hear that person. Yes. So my question is there another way of writing square root of 4?
I said I didn't know, but I'm still trying to see if there's another way.
Okay. Can we write square root of 4 as square root of 2 multiplied by square root of 2? Is that something you think is possible?
No.
Yes or no?
No.
No.
You can't do that. I don't think so.
Yes.
Okay. That's actually yes. The answer is actually yes. It's actually yes. Square root of 4 can be written as square root of 2 multiplied by 2.
No, but the way you put it made it seem as if you were supposed to do the work. Square root of 2 times square root of 2. But if you put it square root of 2 times 2, yeah, you can do that. But you couldn't do it the way you wrote it before. That's why I said no. But yeah, I understand.
Yes. So now you can write it in both ways. You can. This is correct. This one is correct. This is also correct. So both of them are two ways of writing square root of 4.
Okay.
Another way. There's another way of writing square root of 4. There's another way. Does anybody have an idea? Okay, here's the third way. And this third way may be the most important way as far as rational expressions, rational exponents are concerned. A third way of writing square root of 4. Square root of 4 can be written as 4 raised to power 1 over 2. 4 raised to power 1 over 2 is exactly the same thing as saying square root of 4. As a matter of fact, this way is going to be very, very beneficial to us as we move on in dealing with rational expressions today. Okay, so now why is it equivalent? Now let's look at why it is going to be equivalent now. Let's look at why it is going to be equivalent. So let me pick a different color. And then I will say, we know that 4 can be written as 2 times 2, right? True or false?
True.
True.
So 4 can be written as 2 times 2. That's 4 right there. And then we are saying that it is raised to power 1 over 2. On the other hand, 2 times 2 can also be written as 2 raised to power 2. Divide raised to power 1 over 2. So what this thing means is that these two on top is now multiplying with the exponent. So you basically, let me expand this. Let me expand the exponent. So the exponent is like saying 2 times 1 over 2. This is just an expansion I just did here. So, and which is 2, you have 1. So, which gives us 2 raised to power 1, which is 2. Now, let's see if what we just did is correct. I want you to grab a calculator. It can be a cell phone calculator. It doesn't really matter. I want you to press this number, type this number and tell me the result. Type it exactly how I'm going to write it. Type parentheses 4, close the parentheses, type this sign. It is called caret sign. Open another, type 1, divide by 2, and then press enter. Tell me the result.
2.
The 2 you gave me is from your calculator, right?
Yeah.
Okay.
Over here.
You can see this caret sign, this sign is used to represent, is called exponent. For example, I want you to use your calculator. Use your calculator now. Don't tell me anything offhand. Use your calculator and type. Use your calculator and type 3 caret sign 4 and press enter. And let me know the result.
81.
81. Okay. So now this is the same thing as saying 3 raised to power 4. You agree, right? You agree?
Yeah.
All right. So which is the same thing as saying 3 raised to power 4 is the same thing as saying 3 times 3 times 3 times 3. So now, you see, if you can prove it with whole number, then you can also prove it with fraction. You can also prove it with fraction. And this is what the trick, this is the trick that is going to help us in solving so many problems that involves exponents. So many problems that involves exponents. So now let's move on and deal with, just drop the calculator for a moment. Let's move on and deal with other exponents. So now, let's do let me label this example that we just did right here. This is, you can call this example 1, and you can call this one, you can call this example 2, including this, they are all example 2, because we use calculator. And let's do example 3, different ways that exponents can be represented. And let's do other numbers. Okay, so how about if we have a number like this? If we have a number like this, if we have a number like this, x raised to power, no, I want 2 raised to power 2 raised to power x equal to 64. What is the value of x? What is the value of x? So I give you 1 minute to do that. 1 minute, everybody, please. So what do you get as your value of
6.
You got 6?
Yeah.
So how do you get 6? Explain to us, please. Say your
So
first name and explain. Yeah, go.
I put 2 to the power of x equals 2 to the power of 6 plus 2 to the power of 6 equals 64.
Okay.
And
Let me
you
write
said,
that. Let me write down what you said. Then you continue. When I finish writing the first step, you said 2 raised to power x is equal to 2 raised to power 6. Is that what you said?
yeah.
Okay, continue. Yes.
And the answer is 6 because earlier you had said if the base is equal, exponent is equal.
All right. So thank you. Thank you. I like the fact that you quoted that earlier theorem that I gave you, that if the base is the same, that means the exponents are equivalent. So the only thing I need to verify is 64 the same thing as 2 raised to power 6? If that answer is yes, then you are correct. So let's see. 2 times 2 times 2 times 2 times 2. How many 2's times another 2? So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 64. No, I'm sorry. 16 times 2 is 32, and 32 times 2 is 64. So this is correct. So then x is equal to 6. Now I'm going to give you another example now that looks like this one. That looks like this one. Then we bring up another theorem. So I am going to give you something to say. Example 4, 27 raised to power 1 over 3. So the question is evaluate.
Are we going to turn this in at the end of class?
Yes.
Okay.
Plus other things that I will give you.
All right.
You see, what we are doing now is we are bringing up the problem and we are solving it together. So at some point, I will give you the one you will solve by yourself. But we are still solving problems together. I want us to create, I want you to develop the knowledge which you are going to use to solve whatever problem I'll give you at the end of the class. Yeah, go. Evaluate. You have 1 more minute for number 4. So who has an answer for us? I'm going to call names randomly. Eileen Castro, go. What's your answer? Brenna Spriggs, go, please.
I don't have the answer yet.
You are still working on it. Chanel Davis, do you have an answer for us? How about, it doesn't matter. So what's your answer?
I'm just going to get another fraction. I'm not going to get like x equals or.
Yeah, so there's no x on the expression. There's no x. Everything is number. So it can be a fraction. It can be a whole number. We don't know. So I just want to have an idea of what you think. Okay, I'll come back to you. Tatiana, what's your answer? Tatiana, was it Mariama?
Mariama did it.
Yeah, Mariama, how did you get your 3? Explain, please.
I put 3 to the 3rd power in parentheses.
So let me write it. Hold on, let me write it. You said 3 to the 3rd power. You put it in parentheses.
To the power of 1 over 3.
To the power of 1 over 3.
And when I put in my calculator, I got 3.
Okay. Okay, you don't need to put it in the calculator now. So you can just say, let me expand this. Let me expand this side. This is means 3 multiplied by 1 over 3. So 3 cancels 3, and you're left with 1. So it's actually 3. You are correct. The answer is 3. Bear in mind, everybody, bear in mind that you know, of course, you know that there are some questions that says solve without using calculator. Yes, the only reason why I asked you to use your calculator that time, the only reason was to see, for you to verify that when you say 4 raised to power half, that it is the same thing when you use the calculator, that the calculator will give you the same answer. That was the only reason, but that's fine, that's fine. All right, so the answer is 3. So now let's try another one. Let's try another one. Example number 4. Example number 4. Let's say
Number 5.
5 rather. Yes, it's 5. 32. This is 32 raised to power 3 over 5. Do not use calculator and show me. Tell me what to do. You have 1 minute to do this one. So it's still evaluate or simplify. Sometimes they write evaluate, sometimes they write simplify. But this time around, you just say evaluate, evaluate. 30 more seconds. Okay, who has an answer for us? I'm going to call names. Okay, so 1 minute is over. Somebody wanted to say something and then I said, hold on. Who was that? Was that Mariama? Okay, so now, Cindy, do you have an answer for us we can consider?
What I did was 8, and then I put like parentheses 2.
You said you open a parenthesis.
And then I put 2
2
to
yes,
the 5th power.
2 to the 5th power.
Close parentheses.
Close parentheses.
3 over 5.
Okay, 3 over 5.
And it was 2 to the 3rd power.
Okay, so you see 5 divided by 5 is 5. So,
Yeah.
so you're left with 2 raised to power 3.
Which is 8.
And which gives us 8. And that's correct. Thank you, Cindy. That's correct. That's correct. So now that we have written all this, now let me write the general rule, the general mathematics rule. So now here's the general mathematics rule that deals with all these. I'm going to write it beside my screen. You can write it under your paper or beside it, it doesn't matter. So if you have square root of a number C, not really square root, it's called nth root. Nth root of a number C is the same thing as saying C raised to power 1 over n. If you have another number C, raised to power m over n, that is C exponent m over n. It is the same thing as saying square, not really square root, nth root of C raised to power m. It is the same thing as saying. So this is a general rule I just wrote right now. It's a general rule. So if we apply this general rule to this very 32, you can see that 32 is C, 32 is C, m is 3, and n is 5. And once you are dealing with exponents, whenever you see a big number, think about the factors that you can use in order to break down that big number. Once you get those factors and put those factors in the smallest possible term, the smallest numbers. For example, 32 can be 16 times 2. 32 can also be, is it 4 times 8, right? 32 is 4 times 8. 32 can be 16 times 2. So 32 can also be 2 times 2 times 2 times 2. And 2 times 2 times 2 times 2 times 2 is 2 raised to power 5. Okay?